Hi guys, good morning. This video we're going to see the problem number of ways to form a target string given a dictionary. Dictionary means just some words. So let's quickly jump on to the problem statement, and it's pretty big. So yeah, I have just broken down into actual components. So yeah, let's see. It's given that okay, you are given a list of strings of same length, and that list of strings will be inside words, which means words will have a list of string of same length, same length, and a string called as a target string, which I need to make. Your task is to form the target, which I have to make using the words in all these strings under the following rules. What are the rules like? The target, because it needs to be formed, right? So it should be formed from left to right, which means I can't form, I ultimately want to form a target, but it should be formed by picking the elements from left to right. Cool. To form the ith character, 0th index of the target, let's see. To form the ith character, 0th index of the target, you choose the kth character of the jth string in words. So many variables, but still, if the target, what I'll show you. If I want to make this, then it should be same of some jth string in this word kth character. It means that okay, the character should be same. That's all. Once you use the kth character, which means this character, then what happens is of the jth string, of the any string. Here we choose of this particular string, although you can choose any string, but if you choose this character, then what happens is you no longer can use the x character of any string in the words where x is less than equal to k, which means any character less than this whole thing, because it is already you have chosen, so remaining is this whole thing, right? So for the next upcoming element, you cannot choose anything from this white part, you can only choose from the next part. It is what you have to do from left to right. Cool. That it is saying that okay, all these characters becomes unusable. Last thing was that one thing was before this also, that repeat the process until you form the string target. That okay, I choose some, then I choose next, so I have to just form the target. I have to do such steps. Notice that you can use multiple characters from the same string, which means if I want to make A be A, I choose A from the string, let's say 1, then I choose the B from string 2, then again I can choose the string, the character A from the string 1 itself, which means I can choose the same character again and again, provided it should come after. Which means if the A would have been here, I could not have chosen it. It needs to come after this whole thing. Cool. Lastly, our aim is to actually return the number of ways to form the target from the words. Firstly, if you just read this thing, then only you should actually be able to think of what thing needs to be applied here. But still, I'll not name that thing. I'll just show you how you actually reach to that thing. Since the answer may be very large, so for sure, very standard thing, if the answer is large, you return the modulo 189 plus 7. Cool. Now let's see the example to actually figure out, okay, what's happening in the background. If I have these three words, it's the same word which I took in the above example itself. Same, exactly same. I will take the same example in the whole problem. Target is ABA, which means that, okay, what all can be possible. Firstly, I just show, okay, what all can be possible. Then I show how it is being made. Firstly, to make this ABA, I can just grab an A from here, B from string 2, A again from string 1, A from here, B. Now see, B earlier I took this one. Now I can take this one also. So it's same. Okay, I take here. Then again, I grab the A. Then one option is A, B, A. Again is A, B, A, A, B, A, A, B, A. So these 6 ways can be possible to make this target out of these 3 strings. Provided you always saw, whenever I had to choose next element, I just make sure that I'm choosing after this. I can't choose anything before. If I'm doing A, B, I choose B. Then for the next character, I have to choose after this whole line. Now see, what option we have. You saw what option we have. We had to choose a target A, B, A. So one thing for sure that, okay, I start let's take this example only. I start with A. Because I want to make a B A. I start with A, then my next option to choose is B. So I just go choose B. Another option to choose B is next just here, because I just have one condition that okay, after this I need to choose. So whatever I can choose. After that I choose B. B has two options. From this A, I have B as two options. Then from this B right here, for A I have two options. This here and here. From this B right here, I have two options. Right? So what's happening? Wait, let me erase this whole part. And here. From this B2, let's say it is B3. B2, B3. From B2, we have two A's. The A right here and the A right here. From B3 also, we have two A's. A right here and A right here. Which is A2 and A3. And also, in the starting, you started from here, right? What if you had started from, let's say this A right here, the bottom A. The bottom A, if you have started, then you have next option is 1B. For this 1B, which is actually a B3, you have same options. Again, two A's, this A and this A right here, which is A2, which is A and again a A. Right? It is for the top, it is for the last, which means top, last, top, last. You saw what happened. For this B3, top, last. For this B3, you are again finding. You will start with just one A, then again for this B2, you go, B3, you go. Then for B3, for this next A also, your B3 part, which means this next sub-problem part is repeating. You know it's a recursion. You start because you wanted to make the target string, which is A, B, A, but you just start choosing those characters. You just started with that character. Next to choose B, you have two options. Next to choose A, you have again, like for this B, two options, for this B, two options, which is actually four options. And here we have two options. So in total, here you have four options, here you have two options. In total, the options become 6. That's the 6th answer. But you saw what happened. While choosing this B, you again have to think of, okay, let's think of choosing next A's. Same problem occurs here. If you take this A right here, one thing for sure, you know, okay, when I'm trying to choose, problem is being repeated, for sure, it's a DP problem. I need to optimize it via DP. Before that, let's see how you're going to optimize this. Which means what part of problem is repeating that, okay, you know, okay, a sub problem, which means this particular part, let's say BA will come, it will repeat. So I can just grab, okay, number of ways to grab BA, or I can do vice versa also, maybe AB, and then I can just look for again next A. But let's see actually how in this problem we are thinking, what is happening. You saw what happened, that I just showed you that, okay, problems are repeating. Here you can easily see that when I have grabbed these ABs, then again I have to think, I have this next A incoming, next A incoming, next A incoming, next A incoming, which means if I have the number of ways, okay, I can just grab this AB. When is the next incoming? Because ultimately my condition is that anything after this A, anything after this, anything after this. So if I just know, okay, number of ways to grab AB from here up till this point, up till this point, up till this point, and then again I can know number of A's which occur after it. I'll just multiply the number of ways to grab this ABs into A. You didn't get it or you get it. It was exactly the same how I was making. From A, I had two options. Let's consider I had made AB. Now I need to find the number of options to get just A. Here I was just saying, okay, from A, I had two options for B. Then for these B, I have again two options. So let's consider, okay, to get AB, I have three options. Now, what are the number of ways to actually get the final A? Let's see with this example. So what I can do is I can actually make my DP store number of ways to form the target J first characters, which means number of ways I can grab a AB. Ultimately, I want to make a ABA, right? A, B, A. let's take a number of ways to just grab AB, because see, ultimately my main aim is to find the condition which I have to put that okay, I can find the answer for my main string. So let's grab the answer for the small string. Small string is this, main string is this. If I have the answer for the small string, so I should be able to find out the answer for the whole string. It is my aim ultimately. So I just had a bigger problem. I just thought, okay, if anyhow I just got the answer for that small problem, how I will get the answer for my bigger problem? Which means if I had the number of ways, I can get this AB. So Aryan, please give me the number of ways I can get ABAs. Here you can easily see number of ways you can grab AB is actually 3. As I showed you, AB, because it is one AB here, one AB here, and one AB here. So number of ways to grab ABs are actually 3. Now after that, I just know, okay, after this, I just need to think, okay, next incoming thing is A. Number of ways to grab AB is 3. Next incoming thing is A. How many A's can be there? There are 2 A's which can be there. So for these 3 ABs, I can have 2 A's. You saw what's happening, which means 3 A's, 3 ABs and 2 A's. So in total, I have 6 ways to have a ABA. AB, A. In total, 6 ways to grab a ABA. A, AB, A, AB, A, AB, A, AB, A, AB, A, AB, A. That is the reason if I just get to know the answer for the small subproblem, which is number of ways to grab AB, I can just count the number of A's here right now and I can just grab, okay, count of these number of A's. I have, it is my DP of, let's say, J, then it is the count. So I just grab, okay, what is the actual number of ways to form the count of first J characters? That is pretty much it in this DP. Firstly, we just got to know, okay, the problem is being repeating, so it's a DP problem. For DP problem, we just need to know the DP state and the DP condition. The DP state, let's think, but for that, let's see how we'll get the DP condition. We just assumed, okay, let's assume that for smaller subproblem, we have the answer. So how for the whole subproblem we'll get the answer? If for smaller subproblem, I have the answer for number of ways for AB, number of ways to get AB, let's say we have the answer and we get the next incoming A. So how we will just grab the total number of ways to grab this ABA? We just get to know by this condition that I will just multiply number of ways to get AB into the frequency, which means the count of number of ways, and I'll just get the answer. Which means ultimately what happened was the DP state will actually become something like this: number of ways of getting the first J characters of the target. First J characters. I am actually analyzing the first J characters of the target at a particular state and again finding out the result for that particular J characters at point of time. I hope that you guys got it. Which means that the DP of first J plus 1 characters is nothing but the DP of first J characters into the count of this incoming character, which is after this index. Existing first J characters and then new J plus the count of that particular character which is incoming in this condition. Let's see the code. I'll explain actually how the code beautifully is written. See, you just got to know this DP condition, that how actually we are finding the number of new number of ways, which means earlier for AB I know I'm repeating that, but if you have not understood it, you can just skip it. Number of ways we get AB, and then after that we had this A, and then we can find the answer. Let's see the code pretty quickly. It's easy, not that, but yeah, medium. Firstly, I just grabbed, okay, N, M, mod and all that stuff. DP is actually what? I need to make my target, right? So I have ABA. So I just said for this, at every state of those J characters, first J characters of what? Of target. So for sure my DP will have size m plus 1, because I'm just saying for the first character, let's say it's A, so it is DP of 1, which means 1 character. If it is AB, it is DP of 2. DP of 2. For if it is ABA, it is DP of 3. It is just saying, okay, I am analyzing first J characters. It is only analyzing one character only analyzing two characters, first two characters, because for sure we are starting from left to right, analyzing first three characters of this particular string target. Cool. Then we will just grab for sure. I marked my DP of 0 as 1. Why 1? It's because, I am analyzing my DP of 1. So for sure, my result will start from DP of 1 itself and not from 0, because my DP state actually stores for first j characters. So for this DP of 1, as I showed you in the condition itself, if it is 1, so for sure j is 0. If j is 0, so I need to multiply by some count. So initially, if this DP of 0, if this DP, it will be a DP of 0. If it is actually a 0, then the count whatsoever it is there, it will just actually go to 0, because 0 into something is 0. That's the reason I just want, okay, whatsoever count is there, it should come. That's the reason I just put 1 in place of DP of 0. Cool, no worries. Then I have the count. As I said, at a particular point of time, I just need, okay, what is the count of all the A's here? What is the count of all the B's here? Because when I have analyzed this particular index I, then when I am at this index I need to know, okay, I just know, okay, what is the DP of J here? But I also need to know, okay, if the incoming character I need to analyze is the A, then what is the count of A? You can also iterate on this particular whole string, but it's useless. You can just have the count of A, that you can know, okay, AB number of A's are, let's say, 3. Count of A is actually 2 right here. So number of ways to grab AB is nothing but 3 into 2, which is 6. If at this point of time, number of ways to have AB is 3, number of ways to have B after that is 1, because it's just 1, because the count of B is 1. So number of ways to grab AB is nothing but 3 into 1. It's the reason I just grab the count at every index. At every index, whatsoever alphabet character is there, I just had and kept its frequency, so that I can use the same thing while analyzing my DP. Because in the DP itself, I showed you, I need to get the count of this incoming character of what? Of target. Cool, no worries. Then for sure, my actual DP condition starts that, okay, I just go on from left to right. It was said in the question, from left to right, which means increasing the size of the subproblem. I have this A, C, what was the condition? A, C, yeah. A, C, C, A, B, 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 C, A, C, A. So I'm just going from left to right. Okay, I just analyzed first only this, then I analyze only this, then I analyze only this, then I'll analyze only this. It is how I'm just increasing my portion part which I need to analyze. Cool. After that, you will see I'm just iterating on my words, but what I have to think of is of my DP condition. DP of what? DP of, as I said, I need to check for the first J characters of what? Of target. That's the reason I have to iterate on my target also for that particular reason, because I need to get my DP of J. But you will see that I iterated backwards rather than forwards. You will ask why. I iterated from m-1 because I need to iterate on my target itself for every small subproblem. You will see I just iterated from backwards rather than forwards. Is the reason because, as I told you, if I am standing here for this particular I, then I will just check, okay, at this I just check for this particular, let's say A. So I am actually analyzing my DP of 3 because it does the first 3 characters which I am analyzing right now, for which I would need my DP of 2, which means the previous result of AB. But that previous result of AB should be as of before, not this I, as of before, which means when I would have been here, it should have been in the last loop, in the last iteration of I, whatsoever DP of 2 would have been there, it should be coming, which means as of I-1. If I'm standing at I, so as of I-1, I want the DP of 2. Thus, if I just iterate on from 0 to 3, which means from 0 to m-1, then my dp of 2 will actually update as of I, but I want my dp of 2 for my dp of 3 as of I minus 1. I want this as of I minus 1, not as of I, because I want that when I am actually seeing this particular element right here, I should only consider the element, which means AB part. If I'm seeing A right here, I have to consider the AB part as of before, as I showed you this condition. It was marked as of before we need to analyze. That's the reason I just iterated it backwards rather than forwards. I hope that you guys got it. And it is the exact same DP condition which we actually saw above, that our dp of j plus 1 is nothing but dp of j into the count of that incoming character. So it is the same, where it is gone, yeah, dp of j plus 1 is nothing but dp of j into the count of that incoming character. And it is just mod, and as I just added, so I have to do a mod again, because so that it doesn't overflow. Ultimately I have to return the dp of m. Why dp of m? Because it is the final ABAs. See, we need to analyze the first j characters. So first C characters, which means the string size is itself 3, which is m, string size is itself m, target is m. So I need to analyze the first m characters, and it is done. So I have to return a dp of m. That's pretty much it. I know it had been a pretty complex problem, but I hope that I was able to make it understand. Now time complexity is pretty simple. As you look at the code, you will just get to know that we are just iterating on those words, and for every word I'm just going on to every word length. So it is if number of words are w, word length are n, so it is w into n. In this particular dp condition loop, I'm just going on to that word length, and for that I'm going on to every target from reverse, so it is m, which is n into m. That's a condition. It is whole n into w plus n into m. Space is nothing but we are using a dp of size target, which is m, and a vector of count, which is actually n into 26, which is constant, so it is nothing but n into n plus m. All the codes for C++, Java, Python is down below. I hope that you guys got it, that how I thought, okay, anyway I just get the small part, I just get the number of ways to get AB. Now I know, okay, number of A's whatever are there, I'll just multiply the number of ways to get the ABA. Now I have to think, okay, how I will actually find the number of ways of that AB. So basically I just assumed I have the answer for the small sub problem, that I just know, okay, what condition I should apply. Okay, when I know the condition, then I actually get to know, okay, what DP state I should put on that actually, because see, although while explaining, people just explain, okay, you just take a DP state, write this, but actually how you think of is what is required to actually make your DP state as DP of j and not a 2D DP or something else. By just iterating, if you just think, okay, if I have by anyhow the small sub problem, how I will just get the biggest sub problem. By this you will know what is required to have that small sub problem. Anyways, I just need to have what is the number of ways to get these first two characters, number of ways. Then if I have A, I'll just get, okay, what's the number of ways to get ABA. I hope that you guys got it, and see you in the next one. Then goodbye, take care.